In this next chunk of questions, we're going to go over a little bit on tree diagrams. Tree diagrams are a wonderful visual representation of all the possible outcomes, and it really makes us feel comfortable because it eliminates any errors. You can see all the outcomes written out. So, and it's also very helpful when you're dealing with more than 2 or 3 choices. Like in number 17, the breakfast at Strawberry Place has a choice of eggs, French toast, or pancakes. So these are my 3 main choices: eggs, French toast, or pancakes. Now each of them comes with a choice of ham or bacon. So eggs here come with a choice of ham. I'm going to put H for ham, and or bacon. So the same 2 choices will be for the French toast as well, which I'm going to put it under the French toast. And I'm going to make another 2 errors to put them under the pancakes, because I know that each of these 2 will come with the choice of ham or bacon. So also for the pancakes, if I choose pancakes, I know I need to either choose ham or bacon. I'm assuming I'm not a vegetarian. And now I have a choice of drink. So I chose eggs and then ham. And then now I have another 2 choices, another choice to make between 2 options. So I want my B here. And I'm going to take this. So I chose to have eggs. Let's put it a little further down. I chose to have eggs with ham. And then now I have to choose between juice or coffee. Why is this coming up? Oh, juice or coffee. But if I choose not to do the ham, but I said, control copy that. And then I wanted, instead of that, I said, I want a choice of bacon instead. So I want eggs and I want bacon. And then again, between eggs and the bacon, I know I have a choice of juice or coffee. I know this is not perfectly set up, but it's very difficult to do this through Google Doc. But just to kind of like see the way the tree diagram is coming. With the choice of eggs, we have 2 choices, either ham or bacon. And then after we make that choice, then we have 2 other ones to make between juice or coffee. So now our meal has all 3: eggs, ham, juice, or eggs, ham, coffee, or eggs, bacon, coffee, eggs, bacon, juice. These are different types of combinations. And of course, this part has to be, let's just do this again, control copy, and then if we control V, I can make copies. So this can go under there. So I know that I have 2 possible choices for each of my choices, if that makes sense. There is also for my pancakes, ham and bacon, and then I would need to choose my drink. Come on, maybe a little further down. There we go. Last one. There we go. So, and then I need juice coffee, juice. So 2 drink choices for each of these combinations. Coffee, juice, and coffee. There we go. So these are our tree diagram. I want eggs with ham and juice, or eggs with bacon and coffee, or French toast with bacon and juice, or pancake with bacon and coffee. But if we pay attention to our last row, now we can just count all the total outcomes, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we go to number 18, how many total outcomes were possible? We counted 12. Because that's how many total combinations we could get. Now, by using our counting principle, we had 3 choices of eggs, French toast, or pancakes, multiplied by the 2 choices of meat, which was ham or bacon, which was our second event. And our third choice was between juice or coffee. So we had 2 other options there. So 3 times 2 is 6, times 2 is 12. So yes, we did count the same amount and we calculated the same amount, which is, it should come always the same number. 20. What is the probability written as a fraction that will order you eggs, bacon, and juice? So if we go up to our tree, eggs, bacon, and juice, it's only one choice out of all of these 12. So my fraction would be 1, which is my desired outcome, over 12, which is the total outcomes. Now the probability written as a fraction that it will order you a breakfast that contains coffee. A breakfast that contains coffee. Now, we're only specifying the drink. So let's look back up into our tree. How many give me coffee? 1, 2, 3, 4, 5, 6. So I have 6 options that give me coffee out of 12 possible outcomes. And we know that if we simplify this by 6, it is the same as a half. So I have a 50% chance. We know that 1 divided by 2 equals 0.5. And if we multiply that by 100, that is how we get a percent. So we have a 50% chance that we're going to have a breakfast with coffee, as well as we would have a 50% chance of getting a breakfast with juice.